Okay, guys, so this is your help for your study guide here for your test this week. I'm going to do the odd ones, and you only have to do the odd ones, but if you want to earn some extra points and do the even ones as well, you're welcome to. So, to begin with, we're going to talk about multiplication. We talked about a few shortcuts here. So, for the first one, anytime when you have two things that are exactly the same but opposite, two binomials, but they have an opposite sign, that's what we call a conjugate pair, which results in a difference of squares. So you square the first term, you square the last term, you put a minus between them. So my first term is 3, so if I square that, I get 9n squared. My last term is 2, so if I square that, I get 4, and you put a minus between them. The box method will work, but that's faster. As for number 2, 6b minus 5 squared, that's the same thing as 6b minus 5 times 6b minus 5, which means you would just use a box method. But you can also do a shortcut. We talked about that. The way this one works is you square the first term, you square the last term, you multiply those two terms together and double it. The last sign will always be plus. The first sign will always be whatever was up here. So if it was plus, it'll be plus. If it was minus, it'll be minus. And there's a shortcut for that one. So if I apply that shortcut to this problem, if I square the first term, I get 36v squared. If I square the last term, I get 25. If I multiply 6v and 5, I get 30v, and then I double it, I get 60v. The last term's plus. This first term, the last sign is plus. The first sign will be whatever this sign is, which in this case is minus. Okay. That's it for the shortcuts, unfortunately. After that, you kind of just got to use your box method. So in this case, we have a polynomial with 2 terms being multiplied by a polynomial with 3 terms. So we need to create a box that is 2 by 3 in its size. So for the one with 2 terms, I'm going to put that going down the side here. And for the one with 3 terms, I'll put that along the top. And then you just multiply to fill in your box. 8n times 4n squared is going to be 32n cubed. 8n times 2n is going to be 16n squared. 8n times 2 is going to be 16n, and so on. Not always, but usually your like terms will be diagonal to each other. So first of all, we have 32 n to the third power. Cross that one off. And then notice both of my n squareds are right there, diagonal to each other, and then we combine them. Negative 20 and positive 16 together make negative 4. So it's going to be negative 4n squared when we combine those. Then we're going to have our n's, which are diagonal to each other. Negative 10 and positive 16 combined makes a positive 6, and we keep the n. And then finally, the negative 10 doesn't have any like terms to combine with, and we have our final answer. So we have 2 shortcuts there, and then we have an augmented box form. Now we're looking at number 7, which is like a combination of both of those things. We have 2 shortcuts present. We have the squared binomial, and then we have the difference of squares binomials, and then we have a monomial. So when we have this, what I told you guys was to do your shortcuts first. So first of all, I'm going to do my binomial squared. You square the first term, you square the last term, you multiply the terms together. 2 times x is 2x, and then you double it to get 4x. The last term is always plus. The first term will always, or the first sign will always be whatever the sign was originally, which in this case is a plus. Then we have this guy, which is another shortcut. That's the difference of squares one. So you square the first term, square the last term, and you connect them with a minus. After that, go ahead and do your box. So we're going to have to do another box here. It's a 3 by 2 again. I'm going to find an interesting thing happens here with our like terms. Okay, so I've got an x to the fourth. Notice there's no other x to the fourths in there. I've got an x squared, but the diagonals are not like terms this time. So I've got an x squared here. I've got another x squared over here. Negative 9 and positive 4 makes negative 5x squared. Then I have a cubic, which actually, since this power is bigger than a square, I probably should have put that one first. So I'm going to go ahead and take that negative 5x squared. I'm going to move it over here. And I'm going to put the 4x cubed next because you want them to go from highest power to lowest power. It's not like wrong if you don't, but on a multiple choice test, that's how the answers will be written. Then we have a negative 36x, and then we have a negative 36. So there's all of the terms, but we're not done still because there was that 3x in the front and it's still there. So we did the shortcut 1, shortcut 2, then we boxed those two results, and now we're going to distribute the monomial in, just using old school multiplication there. So 3x times x to the fourth is going to be 3x to the fifth, plus 3x times 4x cubed is going to be 12x to the fourth. 3x times negative 5 is going to be negative 15x cubed. 3x times negative 36, okay, 3 times 36, that's going to be 90 plus 18 is going to be negative 108, and x times x is x squared, and then 3x times negative 36 is going to be negative 108x. There's our final answer. So that's multiplication of polynomials. You'll see a couple questions like that on our exam. Then we're going to move into some questions about factoring. Okay, so when it came to factoring, I gave you guys a decision chart to go through. You always start by looking for a GCF, and then after that, if there are two terms, you're going to use the difference of squares approach. If there's three terms or more, you're going to try a box approach, and that's pretty much it. So let's go ahead and take a look at number 9. Number 9, we do have a GCF. All of those can have an x taken out of them. So if I do that, I have 10x squared plus 3x minus 1. If you take x out of x, the negative 1 is what would be left. Now that there's three terms, we're going to go ahead and go with the box approach to factor what remains. So when you're doing a trinomial, the first term goes in the top left box, last term goes in the bottom right. And we're looking for two numbers that multiply to make 10x squared and two numbers that multiply to make negative 1. And when we're done and we complete our box, these two terms should add together to make 3. If they don't, then we've done something wrong. So let's do it. There's 10x. Let's try 2x and 5x. 1 has to be 1 and 1. So if I multiply here, I get 2x, and multiply here, I get 5x. Can these make 3? Yes, they can make 3 if the 2 is negative, which means the 1 would be negative. And so my final answer will be x, my GCF that I took out in the beginning, and then the two binomials that we just got by doing the box, which is 2x plus 1 and 5x minus 1. And no, the order doesn't really matter, which order you have these factors in. You should check to see if you can continue factoring after this. If there's two terms, they would be a difference of squares, but neither one of these, even though they have two terms, are differences of squares. So we are, in fact, done with number 9. Let's go ahead and take a look at number 11. Now, number 11, nothing goes into 25, 10, 20, and 8, and they do not all have x's either. So there's no GCF on this problem, but there are 4 terms, and when there's 4 terms, that's a box method approach. The box method is a little bit different, though, when you have 4 terms as opposed to when you have 3. So you put your first term here, you put your last term here. The other 2 terms can go anywhere. And you just go ahead and factor. Instead of doing guessing and checking, you don't need to because your box is complete. You just need to find what the terms have in common. So in this row, 20 and 25x squared, both of those can be divided by 5, and they both have an x. In this case, both of these numbers can be divided by 2, but you can't take an x out because the 8 has no x to give. Then we do the columns as well. These two terms can both be divided by 5, and they both have at least 2 x's in common. These two terms, the biggest thing that divides into both of those is going to be 4. And there's your answer. You can always double check to make sure if they multiply to fill in the box correctly. But basically you end up with this as your final answer. Let's go ahead and take a look at number 13. Okay, let's check for a GCF 20, 21, and 54. I don't think anything goes into all three of those numbers, and there's no x in common either. So we're going to jump right to the box method, and it's because it has 3 terms. So we put the 20x to the 4th here, and we put the 54 here. Now this one's going to be a little bit of a pain in the butt because these are really big numbers, which means that there's a lot of guesses we'll have to make in order to get here, unless we just get really lucky and happen to pick the right ones right off the bat. But we got to find numbers that multiply to make 20. We also have to find 2 numbers that multiply to make 54. And when we're all done, these 2 boxes should add up to make 21x squared. So let's see. So let's go ahead and just find what makes 20x to the 4th easiest. 5x squared and 4x squared. Split it up almost evenly there. And let's do the easiest thing we can think of for 54. How about 9 and 6? And let's see if this works. So 9 and 5 makes 45x squared. 6 and 4 makes 24x squared. Now can 45 and 24 make 21? Man, I think we just got super lucky. Sure can. Wow, that worked out pretty sweet. If I make this one a negative, it comes out to be negative 21. So here's what I have then. I've got 5x squared plus 6, and then 4x squared minus 9. Now in this case we're not done because we have to check to see if there's a difference of squares, and it turns out that this one is a difference of squares. So we can go one step further now. And the difference of squares method works like this. You take the square root of the first term, put it there and there. Take the square root in the second term, put it there and there. You make 1 a plus, 1 a minus. And at this point now we're done because there's no more differences of squares left. So there you go. Let's go ahead and take a look at the last one, number 15. I don't see any GCF there. And it's 3 terms, so that's a box problem again. 16, x8, and 9. So this is probably going to be 4x4 and 4x4. And let's try 3 and 3. This will be 12x4 and 12x4. And we need it to make 25. 12 and 12 cannot make 25. So these do not add up to make 25. So now whenever you have an issue, when your first guess doesn't work, you try switching the numbers around. But in this case, it doesn't matter because the numbers are identical. So I'm not gonna use those. So let's try something else. What else can make 9 instead of 3 and 3? Well, there's really only one other choice, and it's 9 and 1. So let's see if that helps. If that doesn't help, we might have to try different numbers than the 4s that we have there. All right, so this is going to be 36x4, and this is going to be 4x4. Can those two things make 25? And once again, the answer is no. All right, so we've tried 9 and 1. We've tried 3 and 3. I'm going to go and put 3 and 3 back because I like those better. But so that means the problem was not with these numbers. It was with these numbers. So let's try something else. What else can make 16? Let's try 2x4 and 8x4. So that's going to give me 6x4 and 24x4. Can that make 25? The answer is no. And switching them is not going to matter because we have these identical numbers. You're just going to get the same thing all over again. So I know it's not 2 and 8. There's only one other thing I can try to get 16. I tried 4 and 4, I tried 2 and 8. The only thing that remains is 16x4 and x4, 1x4, right? That's going to give me 48x4 and 3x4, which also doesn't work, but I'm feeling pretty confident that our last shot here is going to help. How about instead of 3 and 3, now we go back to 1 and 9? Ugh. That's not going to work either, because I know this is going to make a really big number here, and this is just going to make 1, so there's no way that's going to make 25. Let's back up. How about we switch the 1 and the 9? So as you guys can see here, it's just a lot of guessing and checking. Get 16 here, and 9, and there it is. That was a really hard one to find. They both have to be negative, though, if I want the middle to make negative 25. So now I've got 16x4 minus 9 multiplied with x4 minus 1. So the box on that one was pretty nightmarish. Let's continue. Now this is a difference of squares, so I would take the square root of the first term, square root of the last term, make 1 plus, and make 1 minus. This is also a difference of squares. Square root of x4 is x2, square root of 1 is 1, make 1 plus, you make 1 a minus. This is not a difference of squares because we can't take the square root of 3 and get a nice integer. This is a sum, so that doesn't work. This is a sum, so that doesn't work. But here we've got another difference of squares. So final answer, the first few terms are all going to stay the same because they're not factorable anymore. But this last one can be broken up again into x minus 1 and x plus 1. There you go. Okay, all right. Moving on, so that's multiplying and factoring is out of the way. Then we also talked about roots and graphing these things. So I'm going to do 17 through 20, and then if you guys want to do 21 through 24 for extra credit, you can. But I won't be doing the second set, so I'll only be doing this first one here. Okay, so they give us a polynomial. They want to know what's the y-intercept. There it is. Easy peasy. They tell us the factored form, so we don't have to factor it. That's nice. They want us to find the roots. The way that you find roots is you take each factor and set them equal to 0 and solve. So 2x minus 1 equals 0, 2x plus 1 equals 0. And since this is written as a square, that really means it's x minus 4 twice. We don't need to set x minus 4 equal to 0 twice, though, because you're just going to get the same answer both times. So here, if we add 1 and divide by 2, we get x equals a half. There's one of my roots. Over here, we subtract 1 and divide by 2, and we get negative half. And then here, we just add 4, and we get 4. So I've got 4 roots. And that's the answer, number 18. Now, number 19 is asking us which of these roots will bounce off the x-axis. The polynomial will bounce off of the x-axis at what root? There could be more than one. In this case, there is only one. The polynomial bounces off of the x-axis whenever the factor, this 4, comes from this factor, right? And it has an even power. When you have an even power there, that's a bouncing root. So at the root x equals 4 is where it will bounce because its factor had an even power. Okay, so now we're ready to graph this thing. Here's how we'll graph it. And I guess I won't make it so big. So at x equals a half, I'll put a little dot right there. At x equals a negative half and x equals a positive half, we have roots. We also have a root at 4. Now we know at this root, it bounces off of the x-axis. We also know our y-intercept was negative 16. 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So we have a y-intercept way down here. And we talked about how you want to start at your y-intercept. So my polynomial is basically going to go up, and it's going to go through that root. It's also going to come up and go through that root. But then it's got to come back down, and then it's going to bounce off of that root and swing back up. And there you go. That's all there is to it. So I'll let you guys do 21 through 24. I think there's a little bit more here for us to do. Let's keep moving on. Second worksheet. I'm going to look at doing long division and synthetic division. Okay, so I'll leave the even ones for you guys, but I'm going to do the odd ones as usual. All right, so first of all, when you're doing long division, this one goes inside the bracket. And you want to make sure that all the terms are there. So I go 3, 2, 1, none. All the terms are there. If they're not all there, then you have to put a 0 in. Same thing with this guy. All the terms have to be there. 2, 1, none. So that one's also complete, so we're good. And what we do is we ask ourselves, what would I multiply x squared by to get 6x cubed? And the answer is I would multiply it by 6x. And then I would multiply 6x by all three of these and put it down here. So 6x times x squared is 6x cubed. 6x times 4x is 24x squared. 6x times negative 2 is negative 12x. And then we go through and we subtract all those, which means it's basically going to change the signs. This is going to become negative, this is going to become negative, and this one's going to become positive. And then we combine downwards. So these go away. 23 take away 24 is negative 1x squared. Negative 16, 12 makes negative 4. Bring down the negative 5. And then we just repeat the process. What would I multiply this by to get this? And the answer is negative 1. I'm going to multiply negative 1 by all three of these. Then we're going to go through and change all their signs. And then we're going to go down and combine them. And as soon as you get to a term whose power is less than this term, then you're done. So this is our primary answer. But we have a remainder of negative 7 over the divisor of x squared plus 4x minus 2. And just so you guys know, anytime the top number here is a negative, they'll sometimes take that negative off and put it where the plus was instead. Okay, so there's your final answer for that one. Let's go ahead and take a look at number 15. This one's asking us to do synthetic division. Synthetic division is the same thing as long division in the sense that every term has to be there, and once again it is. Synthetic division only works when you have a binomial to the first power. So something with a square on it, for instance, or 3 terms or more isn't going to work. It has to be a first degree binomial. How synthetic division works is you take all the coefficients off of these, but don't forget you need a 0 if you're missing a term. Doesn't apply to this problem though. And you put the coefficients there. So 12, 6, 3, 20, and 1. Then you take this number but change its sign and put it there. Bring this number down, multiply, down, multiply, down, multiply, down, multiply, down. This number is always your remainder. This is always your constant. Then it goes up by powers, x to the first, x to the second, x to the third, etc. So my final answer will be 12x cubed minus 6x squared plus 9x plus 11 minus 10 over my divisor, which was x plus 1. And there it is. So that's the end of your study guide. Now, here's your extra credit. I'm not going to work these out. You can watch the videos if you're interested in doing these, but I will display the answers in just a moment. And there you guys go.